Hello CP Math 1, this is Mr. Roberts, and today we're going to talk about solving a system of equations using something we will call the equal values method. As we discussed last week, we have a system of equations if we have two or more equations with the same variables. So here you can see I have a system of equations, two equations, and my two variables are x and y. And what we're trying to do is find the x, y values that makes both equations true at the same time. And because they're both written in y equals form, we can use this technique we're calling the equal values method, because on the one hand we know that y is 3x plus 5, but we also know that y is equivalent to 4x plus 4. So what we're going to do is we're going to use the fact that because y is equal to itself in this context, because it's equal to itself, we can say, therefore, 3x plus 5, which is again that first y, must be equal to 4x plus 4, which is the second value of y. To solve this equation, I'm going to take away 3x from each side. The equation will become 5 is equal to x plus 4. When I do that, I subtracted 3x. And then I'm going to subtract a 4 from both sides. When I do that, I get on the left-hand side the number 1, and on the right-hand side, I get x. So I know that x is 1. Now that I know that x is 1, I need to figure out what y is, and it doesn't matter which equation I choose, both should work. So I'm going to use the top equation. So the top equation says if you want to get y, what you do is you take 3 times the value of x that you found, and you add 5. Y is going to be 3 plus 5, y equals 8. And as a check, it's very nice to plug in the value of x into the second equation also and make sure it becomes x. So in the second equation, it says y is equal to 4 times x plus 4. 1 times 4 is 4. 4 plus 4 is also 8. So we can see in both cases when I put in that x was equal to 1, I got values of y that were both 8. So my solution, the answer to this system of equation, is a point. It's the point where x is 1 and where y is 8. So I write this down as an ordered pair, and this problem is now finished. I have a second example. Again, we know that the top equation tells me that y is equivalent to negative 2x plus 7, and the bottom equation tells me that y is also equal to 1/2 x plus 2. Because in the context of this problem y is equal to itself, we can set the one that I underlined in green, 2x plus 7, equal to the expression that I underlined in yellow, 1/2 x plus 2. As I look at this, I can see across it that there is a fraction, and one of the things that I typically do is I decide to go ahead and multiply everything by a value that will eliminate the fraction, bust the fraction. You can see the only denominator I have is this denominator. It's a 2. So I'm going to multiply every single term on this equation by 2 times 2. So in the first case, when I multiply 2 times negative 2x, it becomes negative 4x plus 2 times 7 will become 14 equals 2 times 1/2 is 1. That just becomes x. And you can see why it busted that fraction, right? When I multiplied 2 times 1/2, it eliminated the denominator. I'm left with just x, and then plus the number 4. What I like about this is I don't have a fraction moving forward. What I'm going to do now to both sides is I'm going to add 4x. This equation will become 14 is equal to 5x plus 4. That was me adding 4x to both sides. Now I'm going to subtract 4 from both sides, so 10 is equal to 5x. And then as a final step, I'll divide both sides by 5, and I get that 2 is what x is. X is the number 2. Now that I know what x is, I need to figure out y. And again, I use both equations just as a check because I should get the same value of y from both equations. From that top equation, I get y is equal to negative 2 times what I found x to be 2, so I'm plugging in 2 plus 7, y equals negative 4 plus 7, y equals the number 3. So in the first equation I get y is 3. The second equation, y is equal to 1 half times 2 plus 2. 1 half times 2 is 1. 1 plus 2 is 3. So I can see that in both cases I got that y was 3, so my solution checks. So when x is 2 and y is 3, these two lines will meet each other. The solution to this system of equations is 2, 3. We're going to do one final problem like this. Again, I have a system of equations, two equations with the variables x and y. And because y is isolated in both, I'm going to use the equal values method. Y is certainly equal to itself. The top equation tells me that y is 1/5 x plus 6. The bottom equation tells me y is 1/2 x plus 3. I'm going to take the first expression for y, 1/5 x plus 6, and I'm going to set that equal to the second expression for y, 1/2 x plus 3. Now that I have that, I can see a lovely opportunity for me to use fraction busters again. Now I have two denominators, right? I have a denominator of 5 and I have a denominator of 2. So I'm going to multiply this equation through by 5 times 2, or 10. Every single factor is going to get hit, every single term rather is going to get hit with a factor of 10. When I multiply 10 times 1/5, 10 times 1/5, that's going to become 2x. 10 times 1/5, that's 10 divided by 5. Plus 10 times 6 is going to be 60, equals 10 times 1/2 is going to be 5x, and then 10 times 3 is going to be plus 30. So now I have a new equation, multiplied everything by 10. I have no fractions. Let's see, I'm going to go ahead and take away 2 x's from both sides. The left-hand side will become 60. The right-hand side will become 3x plus 30. Then I'm going to take away 30 from both sides. That'll give me that 30 is 3x. And if I divide both sides by 3, I get that x should be the number 10. So we have our value of x. Same thing, we're going to figure out what y is. So in both equations, we're going to plug in this value of 10. For the first one, y should equal 1/5 times 10 plus 6. 1/5 times 10 is the number 2. 2 plus 6 is equal to 8. So the first equation tells me 8. Same thing with the second equation. Y is equal to 1/2 times 10 plus 3. 1/2 times 10 is 5, and 5 plus 3 is also 8. So in both cases, when I plug in that y is 10, I can see that these both tell me, I'm sorry, when I plug in x is 10, when I plug in x is 10, they both tell me that y should be the number 8. Let me highlight that in orange. So when I put in that x is 10, I put in x is 10 here and here. Both of those tell me that y should be the number 8. So my solution to this system is the point x is 10, y is the number 8. In Delta Math today, you're going to be doing these problems both ways, the ways that I just discussed, where you take, in this example, the 3x minus 6 and set it equal to negative x plus 2. But I also want you to be able to solve these problems graphically. That's the first thing that you're going to practice. So if I was to graph this system of equations, this first one has a y-intercept at negative 6, and it has a slope pattern of 3, up 3 over 1. So if I wanted to graph that first equation, I would click a point at negative 6, and then I would go up 1, 2, 3 over 1. Right? This is the line y equals 3x, 3 times x minus 6. So that's y equals 3x minus 6. The other line is y equals the opposite of x plus 2. Here my y-intercept is at 2, and I have a slope of negative 1. So I'm going to start here at negative or positive 2, and then I'm going to go down 1 over 1. And there we go. So at this point, I can see that the solution to this system is when x is 2 and y is the number 0. When x is 2 and y is the number 0. If I put in 2 in this top equation, it's going to give me 6 minus 6, which is 0. If I put 2 in here, it's going to be negative 2 plus 2 is also 0. So the solution is x is 0, y is 2. So we would type that in here as an ordered pair, open parentheses, x is 2 and y is 0. And then we would just hit submit. And then one final variation on this. If I give you a system of equations in which y is not by itself, and you can see here y is not alone, you may need to isolate y. So I can graph this top equation. This is y equals 1x plus 8. So I know my y-intercept is at 8 and my slope is up 1 over 1. So this is that first line, y equals x plus 8. The other one, if I subtracted 2x from both sides, this would be the line y equals negative 2x minus 1. Y equals negative 2x minus 1. So negative 1 is my y-intercept, and then I would go down 2 over 1. So here is this one. Right? So again, I had to rewrite this second equation in y equals form, get this y by itself so I could see both the y-intercept at negative 1 and the slope, when this goes over, becomes negative 2. For this one, you can see that there is a solution when x is negative 3 and y is 5. So we would go ahead and type in that value. X is negative 3, ordered pair, x is negative 3, comma, y is 5. All right, there you go. So that is the assignment today. I hope that you do well, and I look forward to see you in class tomorrow and online again.